Hello everyone and welcome back to Diksha Karnataka YouTube channel, and here I am back with the solution for KPL mock test number 2. So today we are going to discuss all the 30 questions that was given to you in the morning, and let's start with all the questions one by one. The first question: a gang capacitor is formed by interlocking a number of plates as shown in the figure. The distance between the consecutive plate is 0.885 centimeter and the overlapping area of the plate is 5 centimeter square. The capacitance of the unit is, so let's see how many capacitors are there. So only this much is considered for capacitor. So this is a gang capacitor, and they have said that area of the overlapping area is 5 centimeter square. So overlapping area means this is the overlapping area, and gang capacitor works only when there is a overlap. Okay, now let us count how many capacitors are there. So 1, 2, 3, 4, 5, 6, 7, 8. So you can see there are 8 capacitors. So 8 capacitors, all of them in this connection, they are all connected in parallel, because if you see, if you consider this is point A, this is point B, so the capacitors you can consider them as like this, right? So all of them are connected in parallel. Okay, so in between there are 8 capacitors. In between there are 8 capacitors like this. Okay, and all of them are at same potential, so you can say they are at parallel combination. So 8 capacitors in parallel combination. First we will calculate the potential for one capacitor. Okay, so what is the formula for capacitance? We know that parallel plate capacitor, the formula is Ka epsilon naught by D. Okay, so here they have mentioned that there is no other medium than air. Okay, so plate area of the plate is given by 5 centimeter square, and the distance is given by 0.885 centimeter. Now we have to convert everything into meter so that we don't have to convert any units, right? So K is 1, area is 5 centimeter square. So 5 centimeter square means 5 times 10 to the power of minus 4 meter square, right? 5 will remain 5, only centimeter square will become meter square. Epsilon naught, we will put the value of epsilon naught as well. Let's move into the next slide and apply here. So C is equals to Ka epsilon naught by D. So K is 1, A is 5 times 10 to the power of minus 4. As I said, epsilon naught is 8.85 times 10 to the power of minus 12, and distance is given by 0.885 centimeter, right? So 10 to the power of minus 2. Centimeter to meter is 10 to the power of minus 2. So what we have to do, we have to simplify these things. Now if you see, this and this are almost same, except if I cancel this, okay, there will be a 10 value, right? So this is basically 0.885, here it is 885, so 8.85. So if I just cancel this, it will be, I can give you one example, 1 divided by 0.1, that is 10, right? Similarly here 8.85 divided by 0.885 is 10, right? Now let's simplify this. 5 times 10 to the power of minus 4, this 10 has plus 1, so plus 1 minus 12, and this minus 2 will go up and it will become plus 2, right? So this is the value. So 5 times 10 to the power of minus 4 minus 12 minus 16 plus 6, so it is 10 to the power of minus 13. Okay, minus 13 is but the answers that is given in our case in picofarad unit. So what we will be doing, we will just simply consider this as 0.5 picofarad, right? So this is 0.5 times 10 to the power of minus 12, right? So now This is capacitance of one capacitor. Okay, don't lose hope. Okay, my option answers is not matching. I calculated one value, but this is for only one capacitor, right? Now there are 8 such capacitors in parallel combination, so it is easy. So the total capacitance or equivalent capacitance is all the capacitors of equal capacitance. So N times C. N is 8 here, C is 0.85, 0.5 picofarad. So that is 4 picofarad. Okay, 4 picofarad. So correct answer is 4 picofarad, option D. So check your answer if you have solved this correctly or not. Okay, now let's move on. A parallel plate capacitor, air capacitor, has a capacitance C. When it is half filled as shown in the figure, with a dielectric of dielectric constant 5, the percentage increase in the capacitance will be. So initially what is there, it was air capacitor. So air capacitor means C equals to K A epsilon naught by D. So single formula, same formula is used multiple times. So A epsilon naught by D. Why A? Because K is 1 for air, right? Now what is said that it is now half filled. Half filled means this distance, suppose initially the distance was D, now this is D by 2, this is also D by 2, right? Now you have to calculate the capacitance. Now if you see this, you can consider as combination of two capacitors. One is this capacitor, one is this capacitor, another one is this capacitor, and they are connected back to back. So basically that means you can consider them two capacitors connected in series, right? You can consider them two capacitors connected in series. So first calculate the capacitance of the air capacitor. Air capacitor is very simple. C1, say this is C1, this is C2, C1, C2. C1 is basically nothing but A epsilon naught divided by D by 2, that is equals to 2A epsilon naught by D, right? 2A epsilon naught by D. So it is basically only 2C. So C1 is 2C. Now we have to calculate the C2. So if you see C2 and C1, they are everything same except there is a dielectric of constant 5. So we can write this as KC1, that is 5 times 2C, right? I told you that whenever there is a capacitor, when dielectric inserted, it becomes K times. Now because they are identical except there is a dielectric, we can use the same concept here also. So it will be 10C, right? Now 10C and 2C, they are connected in series. So in series means equivalent capacitance will be 10C times 2C divided by 10C plus 2C, right? So it will be 20C square divided by 12C. One of the C will cancel and you will get 3 4s are 12, 5 4s are 20. So 5 by 3 C. So C equivalent is 5 by 3 C, right? Now how much it increased? So delta C increase is C equivalent minus C. It was initial value, it is final value. So we have to write it as 5 by 3 C minus C, that is equals to 2 by 3 C. Now this is very simple trivial mathematics, so I am not going to explain how this is coming to be. Now what is the increase? Percentage. So what we have to do to find the percentage increase? Delta C by C into 100%, right? So 2 by 3 C will cancel into 100%, right? So this is basically nothing but 66.6%, right? So let's check what was the answer. Answer is option D again. So option question number 1, question number 2, both are option D. Now let's move on. N identical capacitors are grouped in series and N such capacitors are grouped in parallel. These two groups are connected in series. The effective capacitance of the combination is. So first what is there? We have N capacitors grouped in series. So N capacitors means These are the capacitors, they are connected in series. Now, if identical capacitors are connected in series, I explained this before also, okay. So, it becomes for series combination it becomes so C by N, right, you have to divide by N. Similarly, when they are connected in parallel, then it becomes NC, right. So, now these two combinations are connected in series. So, now we have two capacitors connected in series, one is C by N, another is NC. They are connected in series. Now, total capacitance will be, they are in series. So, equivalent will be C divided by N times Cn divided by C by N plus Cn, right. So, this N will cancel. So, C square divided by C will be common 1 by N plus N, or 1 C will cancel, or C divided by, if you do the LCM, it will be 1 plus N square and 1 N will be in the denominator, that will go up. So, it will be NC divided by 1 plus N square. So, the option is option number C, right. Now, let us move on. Now, two identical capacitors, each of capacitance 5 microfarad, are charged to potential 2 kilovolt and 1 kilovolt respectively. The negative ends are then connected together. When the positive ends are also connected together, the loss of energy of the system. So, first we have to calculate the what are the charges stored in that capacitor. Okay. So, two identical capacitors, each of 5 microfarad. So, 5 microfarad initially was connected to 2 kilovolts. So, what is the charge stored? Q is equal to CV, right. Or what we will do, we first calculate the energy stored in the beginning. Okay, C1 is equal to half CV square, V1 square of C was 5 microfarad 10 to the power of minus 6, V was 2 kilovolt. So, 2 times 10 to the power of 3 whole square, that is half 5 times 10 to the power of minus 6 times 4 times 10 to the power of 6. Okay, so, this is cancel. So, 4 this will be 2, 10. Okay. So, 10 joules is the energy stored in the first capacitor. Second capacitor C2, sorry, this is not C1, this will be U1, right, energy stored. So, U1, and this will be U2. So, U2 will be half 5 times 10 to the power of minus 6, 1 times 10 to the power of 3 whole square, or you can say it will be 2.5 joules. So, total energy of the system at the beginning was 10 plus 12.5 2.5 will be 12.5, right. Now, they have asked you to calculate the energy loss. Now, when they are connected in parallel, they will exchange some charges, their potential will change, and because now let us calculate the charges stored in individual capacitors. So, Q1 is CV1, or 5 times 10 to the power of minus 6 times 2 times 10 to the power of 3 kilovolt, right. So, kilovolt means it will be 10 to the power of 3. So, it will be 10 times 10 to the power of minus 3, okay, coulomb. Similarly, Q2 will be, if you see, it will be 5 times 10 to the power of minus 3 coulomb, right. Same way, only 2 will be 1, right. So, now total charge will remain constant. Total charge will remain constant means when they are connected in parallel, total charge of the system will remain constant. So, Q total will be 15 coulomb, 15 into 10 to the power of minus 3 coulomb, right. Now, what is the equivalent capacitance? Equivalent capacitance will be, they are connected in parallel. So, equivalent capacitance will be simply adding them. 5 plus 5, that is 10 microfarad. Right. Now, what you have to do? You have to calculate the energy of this system. So, energy of this system will be, now energy of this new system will be, let us calculate the new energy, half. Now, we already know Q, we already know C. So, we can calculate the V and then use half CV square. Okay. Or what we can do, we can modify the formula so that we can use directly the value of C and Q directly. So, that will be Q square by C. How to do that? If you forget that, you remember U is equal to half CV square, CV square. Now, Q is equal to CV. So, CV you have to, what you have to do? You have to do C square V square divided by C. So, C square V square is Q. So, Q square by C. In case you forget, that is a trick to just to remember the value. Okay. Now, half Q is 15 times 10 to the power of minus 3, so whole square. So, 15 times 15 into 10 to the power of minus 6 divided by C is 10. So, 5 will cancel, 3 5s are 15, 2, okay, 45. Now, let us put the values, half 15 times 15 times 10 to the power of minus 6. Why so? It is Q square is there. So, 15 times 15 into 10 to the power of minus 3 whole square. So, it will be minus 6, and the capacitance is 10 microfarad. 10 microfarad means 10 to the power 10 into 10 to the power of minus 6. So, this will cancel, right. Now, let us see what is the value. Value will be 2, 3. So, 45 divided by 4. So, it will be about 10.1, right. So, 10.1 is the value. So, what is the reduction? Reduction is change in value. The loss is 12.5 minus 10.1, that is 2.4. Sorry, I made a mistake here. It will be 45 divided by 4, right. So, 4 11s are 44. So, it will be 11 point something, 11.1 by 4. So, 11.25, right. So, it will be 11.25, not 10.11, okay. So, it will be my mistake, to 11.25, that is 1.25, okay. This is a longer method, this is very long method. So, you might be wondering if there is another way to solve this question. So, there is, yes, there is a shortcut method for this. If you want, I am giving that shortcut answer. So, the shortcut answer for this is the loss of energy when such two resistors are connected in parallel after they are charged separately, that is given by half C1 C2 by C1 plus C2 times difference in potential, okay, V1 minus V2 whole square, okay. Difference in potential, it can be V2 minus V1, it can be V1 minus V2 based on the difference in potential. So, it will be half C1 was 5, C2 was 5. So, basically you can write this as simply 5 by 2 times 2 kilovolt, that means 2000 minus 1000. That is one more thing I have to consider, that is they are in microfarads. So, it will be half 5 by 2, since they are all equal capacitance, I can write this, right. 5 times 5 divided by 10, it will get 5 by 2, okay, if you are wondering. Then it will be 2000 minus 1000 whole square. So, it will be 5 by 4 times 10 to the power of minus 6, 1000 square. 1000 means what? 1000 means 10 to the power of 3, right? 1000 means 10 to the power of 3 and whole square of that is 10 to the power of 6. So 10 to the power of minus 6 times 10 to the power of plus 6. So they will cancel each other. 5 by 4 means 1.25. Okay, 1.25 joules. So you can easily answer this question if you remember this formula. Previous one was detailed method where you don't know the formula, you have forgotten the formula, but you know half CV square is the formula. But if you remember this formula, particular this kind of problems, then it will be very beneficial. You can solve very quickly. Now let's move on to the next problem. The capacitors 4 microfarad, 6 microfarad and 12 microfarad are connected in series to a 12 volt source. The charge in the middle capacitor. Now if you remember that they have given you 3 capacitors. Okay, and they are all connected in series to a battery. Now when they are connected in series, you should remember that all the capacitors will have same amount of charge. Same amount of charge will be there for all the capacitors, including the equivalent capacitor. Including the equivalent capacitor, all of them will have the same capacitor. So what we will do, we will find the equivalent capacitance and then we will find the charge in that equivalent capacitance. That will be same as the middle capacitor, at the first capacitor, at the third capacitor. All capacitor will have same charge. Okay, what is the equivalent capacitor when capacitors are connected in series? So 1 by C equivalent, there are 3, so we cannot simply write C1 C2 by C plus C2 because there are 3 capacitors. So it will be 1 by 4 plus 1 by 6 plus 1 by 12. LCM is 12, so it will be 3 plus 2 plus 1, so it will be 6 by 12, so it will be 1 by 2. So C equivalent is 2 microfarad. The charge will be Q is equal to CV. C is 2 microfarad, 2 times 10 to the power of minus 6, and V is 20 volts. Okay, so it will be 40 times 10 to the power of minus 6 coulomb or 40 microcoulomb. Okay, so the correct answer is 40 microcoulomb. Okay, be careful when you are answering such questions. You have to be careful and try to understand the concept behind such question. How many 6 microfarad 200 volt capacitors are required to make a capacitor of 16 microfarad 600 volts? Similar problems we have solved in the yearly problem as well. So what is the main funda is that here you have to first construct a capacitor which can withstand 600 volt. To increase the potential that it can withstand, you have to connect them in series, because in series the potential is divided equally, right? If they are equal, then potential is divided equally. So what is the main funda is that all the 6 first we have to connect 6 capacitors in series so that we can calculate the voltage. So through 200 here, 200 here, 200 here, so 600 voltage done. Now what is the equivalent capacitance of that? Equivalent capacitance when connected in series, equal capacitors, it will be just divided by the number of capacitors connected, right? 6 divided by 3, so it will be 2 microfarad. Okay, now what is the desired capacitance? Desired capacitance is 16. So how many capacitors are needed? N equals to 16 divided by 2, that is 8 such combination, 8 such combination. Now in each combination how many capacitors are there? In each combination 3 capacitors are there and we need 8 such combination. So total number of capacitor 8 times 3, that is 24 such capacitor is needed. So correct option is option D. Okay, now let's move on. 2 capacitors marked 12 microfarad 200 volt and 24 microfarad 200 volt are connected in series. The combination acts as a capacitor with breakdown voltage. So now here we have 2 capacitors, 12 microfarad 200 volt and 24 200 volt. So first 12 they are connected in series. Okay, in series what happens? Their potential increases. Now let's see what is the equivalent capacitance first. First we will calculate the equivalent capacitance. To calculate equivalent capacitance, we do not need to consider the breakdown voltage, right? So first we will calculate the equivalent capacitance. They are in series, only 2 capacitors, so we can simply use this formula. Okay. Okay, so 8 microfarad. Now in 8 microfarad there are 2 options. One is 300 volt, one is 400 volt. So we have to calculate the breakdown voltage. How we can calculate the breakdown voltage? When they are connected in series, their respective potential adds. Okay, so in the maximum condition, this will have a 200 volt. This will also have a 200 volt. This is the meaning of it, right? So the total potential this combination can withstand is 400 volts. So total potential it can withstand is 400 volt, and equivalent capacitance is 8 microfarad. So correct answer is option B. In series, the potential adds up. Okay, in parallel, it should be the minimum value of the combination. Okay, suppose I say I parallelly combined one capacitor of say 100 volt. Another one is 200 volt. What is the breakdown voltage? Now the breakdown voltage should be the minimum value, that is 100, because if you apply more than 100, okay, this capacitor will remain fine, this capacitor will break down. So this combination will no longer function. So minimum value is whatever the minimum value for parallel combination. For series combination, it adds, directly adds. Okay. A conducting sphere of radius r carrying plus q is connected to an uncharged conducting sphere of radius 2r. The charge that flows between them. So this is basically a electric potential question. So we have a sphere, uncharged sphere. First we have a charged sphere of carrying q. This has a charge q, and then we have another sphere of radius 2r. Okay. Now when we connected them, what happens is this has some potential, this had some potential, and now this had zero potential. They will exchange the charges till their potential is same. Now what is the initial potential of this? Not initial potential. Suppose after initial potential is not important in this case. Suppose after the exchange of charges, this becomes now Q1, this becomes now Q2. It has now Q1 charges. So what is the potential of this sphere? K Q1 by capital R. That is the potential of a sphere, right? For this, it will be V2 will be K Q2 by 2R. Now, initial charge of the system was capital Q. Only this sphere had this charge. So, what else we can write? We can write Q1 plus Q2 should be equals to capital Q, right? This also we can write. Now, what else? When they are at balanced condition, okay, these two potential must be equal. So, we can write here that V1 must be equals to V2, right? Now, if you compare these two values, what will be the relationship between Q1 and Q2? So, K Q1 by capital R equals to K Q2 by capital 2R. So, we can cancel and we can see Q2 is 2Q1. Okay, if you just need to cancel them, cancel K, R cancel. So Q2 is 2Q1, right? Also we know that Q1 plus Q2 is capital Q. So let's put this value here, Q1 plus 2Q1 is equal to Q. So Q1 is basically Q by 3, right? Now initially this sphere had capital Q charge, and out of that only this much charge is left. So remaining charges has flown from here to here, basically Q2. Basically Q2 you have to find. So what is Q2? Q2 is basically 2 times Q by 3, that is 2Q by 3. You can calculate it by doing subtracting from Q1 or using this method. Both method you will get the same value. Okay. So the correct answer is option D. Okay. This is a simple but little bit tricky question. Now, the charge deposited on the 4 microfarad. Whatever the charge deposited on this, that is the question. How much charge is deposited on this capacitor? So first what we will do? we will try to find out the potential across this. These two are connected in parallel combination, so they should have the same potential. So first what we will do, we will find the equivalent capacitance of these two combinations, these two capacitors. They are connected in parallel, right? So parallel combination means their combination will be simply added, right? So the equivalent capacitance for this combination will be 4 plus 2, that is 6, right? So we can simply draw this circuit as right. So this will be only 6, this is 6, this is 6, right? Now what is the equivalent of this entire circuit? Equivalent of this entire circuit is just they are in parallel, both of them are 6. So the combination, the final value will be 3, right? It will be just, if they have same value, I told you same value C by N. Same value C by N. How many? What is the capacitor? 6. How many capacitors? 2. 6 by 2, that is 3, right? Now 3 microfarad and 12 volt. So let's calculate the charge. Charge will be Q is equal to CV. This part you can do immediately and it's very simple if you practice. From now on, there is mathematics is starting. So Q is equal to CV. C is 3 microfarad and volt is 12. So 36 times 10 to the power of minus 6. This is the charge. Okay, this is the charge of this entire system, right? Now the same charge will be there for this combination as well, right? If you go back one stage, if you go back, because this is an equivalent capacitor, if you go back, that same thing will hold for the previous stage as well. Previous stage means when 6 volt, 6 microfarad and 6 microfarad are connected in series, right? Now, so there will be 36 microcoulomb here, 36 microcoulomb here, because they are connected in series. Now you cannot say the same thing for this, because they are in parallel. Parallel, they are distributing the charges, so that someone has more charge, someone has less charge. Now which one has more charge? This one has more charge, this one has less charge. So what is the charge here? Suppose now they have same potential. Same potential means Q1 is equal to C1 V, Q, or V is equal to Q1 by C1, and again V will be equals to Q2 by C2. Okay, now Q1 plus Q2 is this value, right? So this is Q1, C1, Q2, C2. The potential across them is same, that is V, right? In parallel combination, potential is same. In series combination, charge is same. Now we just need to compare them. If you compare them, you can calculate Q1 and Q2. So what is Q2? Q2 is 2. Sorry, not Q2 is 2, sorry. C1 is 2. C2 is 2. So Q2 by 2 is equal to Q1 by 4, or Q1 is basically 2Q2, right? Or Q2 is Q1 by 2. Now we know that Q1 plus Q2 is 36 times 10 to the power of minus 6, or Q1 plus Q1 by 2 is 36 times 10 to the power of minus 6. Okay, or Q1 plus Q1 by 2, that is 3Q1 by 2. So 3Q1 by 2 equals to 36 times 10 to the power of minus 6, right? So it will be 12, or Q1 equals to 24 times 10 to the power of minus 6. Okay, Q1 is 24 times 10 to the power of minus 6. So you can answer this. This is a little tricky question, not exactly straightforward, but if you solve it step by step, you can answer this question. Now next question. All capacitors used in this diagram are identical. Each of these capacitance is C, then effective capacitance between the points A and B. Now this is a very particular problem, particular style of problem. Here, first of all, you have to understand how these capacitors are connected. If you see there is no capacitor here. They are connected like a wire. So let's start with this half first, up to this point. Okay, how they are connected, we have to understand that. If you understand that, okay, in future if they have given you some difficult combination, this is little harder compared to CET standard, but last year CET question paper was not so simple. So maybe this is this can be coming to your CET exam next year, right? So don't guess, even though CET overall paper standard is little bit easier. Last year CET question paper was not so simple. It was slightly above average. Okay, so now if you see, these points are connected, right, using a wire. So if there was a 2 points are connected via wire, we can simply connect them together. So we can, what we will do, we will take this point and we will take it and we will connect it. So what is that means this point is connected. We are first considering only these capacitors, C1, C2, C3. First we are considering only C1 and C2. Okay, so these 2 points are pivoted, right? These 2 points are pivoted. So we can see this point is already here. These 2 points are connected here, and these 2 points are connected. So these 2 points are connected like this. Okay, so now let us focus on C3. C3, this end is again connected to the starting point, right? So this point is connected to the starting point. Okay, and ending point is again connected to this point, right? So we can say this is the combination. So basically this is nothing but 3 capacitors in parallel combination. Okay, similarly, if you consider the other half, there are also 3 capacitors connected in parallel combination. So another 3 capacitors connected in parallel, and the entire thing is then connected in series. Understood? So this is the only thing that you have to understand. If you are getting some question, try to figure out how they are connected. How they are connected, if you can figure them out, what are all the common points. So this is common points, these are common points, then you will be able to answer such questions. Now if all the capacitors are identical, they are connected in parallel. Parallel combination means everything is equivalent capacitance will be n times, that is 3 times. So total capacitance of this is 3C. This is also 3C, right? Both of them are 3C. Now they are connected in series. So 3C in series. So 3C in series. Okay, you can use C1 C2 by C1 plus C2, but since they are at equal values connected in series, so it will be 3C divided by 2, C by N, right? So total capacitor will be 1.5 C. So 1.5 C is the answer. Okay, but let's move on to the next question. Two parallel plate capacitors of capacitance C and 2C are connected in parallel and charged to a potential difference V. The battery is then disconnected and the region between the plates of the capacitors of capacitance C is completely filled with the material of dielectric constant K. The new potential difference across the combination is. So first, what is happening? C and 2C are connected in parallel, right? And then they are connected to a battery of V. So C and 2C connected in parallel. Parallel means the equivalent capacitance is just adding, right? So I am just drawing the equivalent capacitance in the first stage. So equivalent capacitance will be 3C, right? In parallel combination, they are just added. So equivalent capacitance is 3C. Now, what is the charge stored? The charge is always conserved. You remember that charge always conserved. So the charge stored is, suppose the first charge is Q. Q is 3C times V, right? Q is equal to CV. So here C itself is 3C. So 3C into V, this is the charge stored in the capacitor. Now what has happened? Now the second capacitor, we have increased the capacitance by inserting a dielectric of dielectric constant K. So what is the capacitance in this case? The capacitance in this case will be K times C, right? If you add a dielectric, the capacitance increases K times. Okay, so the capacitance will be Kc, the total new capacitance will be 2C plus Kc, that is 2 plus Kc. Okay, now if the voltage is V1, now charge will remain same, right? So the charge will remain same. So we already calculated the capacitance. Now new potential is V1. Now you just need to compare this to, very simple problem, not a difficult one, this one. Okay, so 3CV is equal to 2 plus KCV dash. So V dash will be, CC cancels, it will be 3V divided by 2 plus K. So 3V divided by 2 plus K, K plus 2 here. Okay, so this is the option, answer. Simple problem. An air-filled parallel plate capacitor has a capacity of 2 picofarad. The separation of the plates is doubled and the interface is filled with the wax. If the capacity increases to 4 pf, the dielectric constant of the wax is. Now we know that C is Ka epsilon naught by D. This is the first case, right? In first case, K was 1 because there is air only, right? So in the first case, K is 1. So what we will do, this is given by 2 picofarad. Next, C dash is, it is filled with the dielectric constant, say K. K, A remains constant, epsilon also constant. D is doubled, right? So D is doubled. Okay. Now this capacitance is 4 picofarad. Okay, now let's simplify this K by 2. A epsilon naught by D equals to 4. Now A epsilon naught by D is 2, right? So what we will do, we just need to write it, K by 2 times 2 equals to 4. 2 cancels, so K equals to 4. Right? Simple problem. If you just follow the steps, you will be able to answer this question. You need to practice more and more. If you are not able to solve these easier questions, difficult question I can understand. Well, this is a little bit difficult question. I need to practice a little bit harder. I have to understand the concept. But these are easy questions. If you are not able to answer these easy questions, that means you are not practicing simple problems. You are not watching the videos properly. You are skipping in the video in the middle. Now, two capacitors each having capacitance C and breakdown voltage V are joined in series. The capacitance and the breakdown voltage of the combination is. So two capacitors each having same question, similar question. Okay, so when it comes to breakdown voltage, when connected in series, okay, their voltage increases. Okay, parallel, it is the, if between two capacitors the minimum voltage is the breakdown voltage, but in series it gets added. So the breakdown voltage will be 2V and this is C, this is C. So the equivalent capacitance will be C by 2, right? So C by 2 and 2B. So correct answer is option D. If there are n capacitors in parallel connected to V volt source, then the energy stored is equal to. So n capacitors in parallel. N capacitors in parallel means what is the equivalent capacitance? Equivalent capacitance is NC, parallel combination. Okay, and we know that energy stored is NC V square. Right, equivalent capacitance. If you can calculate equivalent capacitance, we can simply calculate the energy stored, that is half NC V square. Not super difficult, it's very simple problem. Okay, now next problem, a sheet of aluminium foil of negligible thickness is introduced between the plates of a capacitor. The capacitance of the capacitor. Now if the thickness of the dielectric medium is negligible, it does not affect the capacitance, so it remains unchanged. Okay, negligible, you should remember that negligible thickness does not affect anything. Maybe it is metal of having infinite dielectric constant. If it is negligible, you can neglect it. Okay, so remember that. Unless and until it's very fine case where you are dealing with very fine values, otherwise you can simply ignore that. A parallel plate capacitor is made by stacking equally spaced plate connected alternatively. If the capacitance between two adjacent plate is C, then the resultant capacitance is N equally spaced. Now parallel combination is made. Now let us see how many capacitors we can make if we can stack up 4 such plates. How they are connected? They are connected alternatively, right? So alternatively means this. If you consider 5, then it will be this. Now let us consider 5 only. How many capacitors we made? 1, 2, 3, 4. So if there are 5 plates, we have completed 4 capacitors. If there are 6 plates, we will be completing 5 capacitors. That means how many number of plates are there? The number of capacitors will be n minus 1. Right? N minus 1, each of capacitance same value, that is C value, right? So the equivalent capacitance will be n minus 1 times C, NC, right? Here instead of n, it is n minus 1. So n minus 1 times C. A parallel plate capacitor with air between the plates has a capacitance of 9 microfarad. The separation between the plate is D. The space between the plate is now filled with two dielectrics. One dielectric has a dielectric constant K1 is equal to 3 and thickness D by 3, while the other has a dielectric constant K2, 6 and thickness 2D by 3. Okay, the capacitance of the capacitance is. So what is the diagram of this? Let us draw the diagram of this combination. We have this is the capacitor. Okay. Initially, what is the capacitance? It was filled with air, right? And that value is given 9 microfarad. Now, D by 3 is filled with 3. So, suppose this is D by 3. Here K is 3 and this is 2D by 3 and this is K is equal to 6. Now, as I discussed in the previous problem as well, you can consider these as 2 separate capacitors connected in series. Okay, one with D by 2, another one is D by 3, they are connected in series. So what we will do? First we will calculate the individual capacitances and then we will simply find the combination in series. So let's do that. So C1 is K is 3. Let me use the values directly. 3 A epsilon naught by D by 3. So this D will go up and it will become 9 A epsilon naught by D. So that is 9 times 9, that is 81 microfarad. Right? Now what is C2? C2 will be 6 A epsilon naught divided by 2D by 3. If you see, actually you will get same 9 times 9, 81 microfarad. The data and values are given such that you are getting 81 microfarad in both the cases. Okay, now they are connected in series. In series combination, what is happening? The equivalent capacitance is both of them are same value. So what we can do? We can simply use our old rule. Okay, capacitance of any one of the capacitor divided by number of capacitors. So it will be 40.5. So 40.5 means option C is the correct answer. Okay. Now a capacitor of 4 microfarad is connected as shown in the circuit. The internal resistance of the battery is 0.5 ohm. The amount of charge in the capacitor plates will be. So this is basically a mixed concept of capacitance as well as circuit diagram. So now they have given you the internal resistance. Okay, so internal resistance is 0.5. Okay, now how much potential drop is happening across this? For that, what you have to do, first you have to find the current. While finding the current, we will assume this is just there is nothing. Okay, so what is the current in the circuit? Current is given by, when the capacitor is fully charged, okay, there will be no current in this circuit. Capacitor is fully charged, so potential difference across them, across these 2 points and this point will be same. Okay, these 2 points and these 2 points will be same. Okay, so there will be no current. Only current that will pass is this direction. Okay, in this circuit. Now, what is the current in that circuit? So let's say this current is I. So I will be V equals to IR. So I will be V by R. So V is 2.5 divided by 0.5 plus 2. That is 2.5 divided by 2.5. That is 1 ampere. Right? 1 ampere is the current. Now, if 1 ampere current is flowing in the circuit, then what is the terminal voltage V? Then what is the terminal voltage V? V is basically, if you remember, epsilon minus IR. Right? Epsilon minus IR. Epsilon is 2.5, I is 1. I is 1 and R is 0.5. So it will be 2 volts. The same volt will be there across the capacitor as well. So this is the potential across this this terminal. So same potential will be across the capacitor as well, because there is no current, so there is no drop across this resistor. Okay. So what we have to do, we have to find the charge. So Q equals to CV. V we have calculated 2 volts. C is given 4 microfarad. And V we have calculated 2. It will be 8 microcoulomb. So 8 microcoulomb is the answer. So only thing that is you have to calculate is the terminal voltage. To calculate terminal voltage, you have to calculate the current. So it is a simple application of current into the concept of potential. Okay. Now, here this is a very interesting question. I am going to solve it very quickly. So here, if you start with the last, whenever this kind of combination is given, you have to start with the last part, okay, where there is no other things are connected. So if you start here and if you see they are all connected up to this point, they are all connected in series, right? All of them are 6 ohms, 6 microfarads. So 6 microfarads are connected in series. Series means it is N by 3. C by N. Okay, all of them are 6. So this capacitor can be removed using a single capacitor. What will be the single capacitor? That will be 6 by 3. So you can remove this by using a single capacitor. It is equivalent capacitor I am drawing with red. That equivalent capacitor will be 6 by 3. That will be 2 microfarad. Right? Now 2 microfarad is connected in parallel with 4 microfarad. So the till this point, if you calculate the equivalent capacitance, that will be another 6, right? 4 plus 2 is 6. Now again there are 3 capacitors, 6 microfarad and 4 microfarad. So till this point you can easily say they are all another 6, right? So here this is 6 by 3, that is 2. 2 plus 4 is 6. 6, again 3 6s. So again 2, another 2 here. Another 2 here. 2 plus 4, again 6. That 6. Again 3 6s are in series. So 2 microfarad. So final answer will be 6 by 3. That is 2 microfarad. Okay. Simple calculations. Okay. Only thing you have to understand the diagram and visualize the diagram, how you can solve these questions. Okay, these questions required little bit of practice. A wire of circular cross section of diameter 0.08 millimeter is made of an material whose resistivity is 1.6 times 10 to the power of 6 micro ohm centimeter. if the resistance of the wire, sorry, this won't be micro ohm, this micro is incorrect, I guess that is been corrected in your question paper. Okay, whose resistivity is 1.6 into 10 to the power of minus 6 ohm centimeter. If the resistance of the wire is 21 ohms, the length is, so we know that R is equal to rho L by A. Okay, here they have given you circular cross section of diameter 0.08 millimeter, right? So what is the radius? Radius will be half of that, that is 0.04 millimeter. So what is the area? Area is pi r square. Now millimeter is basically, if you convert millimeter into meters, let me convert everything into meters. Okay, later on we will see how much centimeter or meter is the answer. Okay, first we have to convert everything into meters. So 10 to the power minus 3 pi r square. Okay, or pi 0.4 means 4 times 10 to the power of minus 2, 10 to the power of minus 3 whole square. Now they will 10 to the power of minus 2 and 10 to the power of minus 3, if you multiply them, their indices will be added, that is 10 to the power of minus 5, right? 10 to the power of minus 5 will be the indices. Now you just square them, pi times 16 times 10 to the power of minus 10, right? Now put the values here. So 21 is given 21 ohms, rho is given 1.6 times 10 to the power of minus 6. Okay, and L we are trying to calculate. A is this value, pi times 16 times 10 to the power of what? Minus 10. Okay, now calculate L. L equals to 21 times pi times 16 times 10 to the power of minus 10 divided by 1.6 times 10 to the power of minus 6. Okay, so now there is a 16, this is 16, right? Let us calculate this, simplify this. Again, here 16, 1.6. I just did similar problem before, where I have cancelled 8.85 divided by 0.885 by 10. Similarly, here will be also 10. So 21, L will be 21 pi. Now let me write pi as another familiar value, 22 by 7. Okay, why? This is 21 is there, so we will use this opportunity to cancel. Now 10 to the power of minus 10, and this will go up and it will become plus 6, right? So 366 10 to the power of minus 4 plus 1, that is minus 3. Okay, this much meters. Okay, so the correct answer is 66 into 10 to the power of minus 1 centimeter, or 6.6 centimeter. Don't get confused, many people have answered this, I know. So if you are answering honestly, you have to be careful about 10 to the powers. Now next problem. A wire of resistance 10 ohm is drawn out of 3 times its original length. The new resistance of the wire will be, I have given you a shortcut formula. If you know that new resistance is the how much you have changed the length times, that is 3 times, it has been 3 times, square the old length, old resistance, right? So 9 times 10, that is 90 ohm. If you are still confusing how I solved, you go back and check my lecture where I have discussed this thing. Okay, if a flash gun of camera operates for a milliseconds and during this time 0.05 coulomb charge is flow, then the current will be, okay, current is Q by T, delta Q by delta T basically. So delta Q is 0.05 coulomb. Okay, and time is 10 millisecond. Millisecond means 10 to the power of minus 3 seconds. So this will be 0.05 times 10 to the power of 3. Right, or it will be 50 amperes. So current answer is 50 amperes. Be careful when you are treating 10 to the powers. Again, simple problem. At 1,000 degrees Celsius, a resistance of a wire is found to be 4 times its resistance at 0 degrees Celsius. Calculate the temperature coefficient of the resistance of the material of the wire. So R1000 is 4R. So if R0 is R, then R1000 is 4R, right? Now I already told you the temperature coefficient is R T minus R naught divided by delta T R naught, right? So RT is 4R minus R divided by delta T is 1000 minus 0, that is 1000 times R. So 3R divided by 1000R. R cancels, it will be 0.003. So 0.003. Simple. Next problem. If R1 and R2 are respectively the filament resistance of a 200 wire watt bulb and a 100 watt bulb designed to operate at the same voltage, then which of the relationship is correct? We know that right, this also I told you. So for first bulb, say everything is this. Now they are operating at the same voltage. So V1 is same for both the bulbs. So R2, okay. So R1 by R2 is P1 by P2. We will cancel automatically. So R1 by R2 is 200 divided by 100, that is 2. So R1 is 2R2. Okay, so R1 is 2R2. And this is a very interesting question. IV graph for a metal and temperature of T1, T2, T3 are given. The temperature is related as. So now, as temperature increases, we know that resistance increases. So resistance increases means it will have a very low current for same voltage. Now let us take a point where let us consider this is a fixed voltage point, and we will calculate the current for each temperature at this voltage. So if you see, this has the lowest current and this has the highest current. T2 is in between. In between points are easy. In between will be either this or this. Okay, so because T2 will always be in between, and temperature changes means current always changing. That means this is not correct. This is not correct, and this is also not correct because T2 is in between, so that will be in between value, right? Only which is highest, which is lowest, that is the important thing. Now at this temperature, current is maximum. So that means T3 must be the lowest possible temperature. T1 is the highest possible temperature, because as temperature increases, resistance also increases. Resistance increases means current decreases. So T3 is the lowest value and T2 is the highest value. So this is the lowest value, this is the highest value. So correct answer is option A. In this case, T3 is highest, T1 is lowest, which is not correct, right? Vd is the drift velocity when a current flows through a wire. If the radius of the wire is doubled for the same current, the velocity of the electron, drift velocity of the electron will be. Now we know that I equals to NEA Vd, right? Here N is number of charges per unit volume, E is the charge of an electron, A is the area. Okay, current is constant. Number of charges does not change, volume density does not change, charge of an electron is constant, only what is happening, A is changing. So initially suppose the area was A1 and the radius of the wire is initially say R, so it will be pi R square. Now finally we have doubled the radius, so double the radius means 2R whole square, that means 4 pi R square. Okay, so initially what is drift velocity was given by this relation. Okay, A1 instead of everything A1, and let's say the drift velocity is D1. Everything else is same. Secondly, current is same, N is same, E is same, area changed to A2, and the drift velocity is at D2. Okay, now if you see here, this is A1, so it will be 4A1. Okay, so let me write it here, 4NE A1 V D2. Now just divide them. So divide them, then you will get 1 I by I, that is 1, equals to V D1 by 4 V D2, or V D2 or V D2 is equals to V D1 by 4. So drift velocity decreases. Okay. Now next problem, wire of certain material is stretched slowly by 10%. Its new resistance and specific resistance becomes respectively. Specific resistance remains constant. I think I have solved this question during my classes. So specific resistance remains the same. Okay, so only one option is okay, there are two options, both remain same, and another one is this one. Okay, now you don't need to solve it. As the length is increasing, the resistance will definitely not remain same. So the correct answer is option A. Okay, in this case you don't need to solve anything, you just simply by reading the options. Okay, specific resistance does not change, so only either possible option is C or possible option is A. Now you are changing the length, so resistance will definitely increase, and in this case they have mentioned both will remain same. That is not possible, so correct option is option A. The effective resistance of the between P and Q for the following network is. So what is the effective resistance between these two? It is very simple. These two resistances are connected in series. So they are connected in series means 3 plus 3 connected in series. So total resistance will be 6 ohm. So first resistance is 6 ohm. Okay. Then another 6 ohm is connected in parallel, right? They are connected in parallel. Okay. And then this combination is connected in series with two more resistances. Okay. They are connected in series, 4 ohm and 5 ohm. Now 6 and 6 connected in series. They are equivalent, connected in parallel. They are equivalent to capacitors connected in series. So the equivalent resistance will be 6 by 2. Both of them are same value, so it is easy for us. So we can write this as 3 ohm. Now everything is in series. 4 plus 3 plus 5, so 7 plus 5 is 12, so 12 ohm. Okay, very simple problem. Okay, if you just understand the basics of resistance in series and parallel, you can solve this. This is an interesting problem. Calculate the potential difference between A and B. Okay, so they have asked you to calculate the potential difference between A and B. Now this is, if you see, they are parallel combination. In parallel combination, the potential is same for both the resistors. Okay, and in this case one resistor and the current through that is given. So whatever potential is across this resistor, the same potential will be across this resistor because they are connected in parallel. Now what is the potential across this? Current given, resistance given. So V is basically 2 times 3, that is 6 volts. Okay, so that is simple question. Okay, this is just to trick you. Now in this electric circuit shown, each cell has EMF of 2 volt and internal resistance of 1 ohm. The external resistance is 2 ohm, the value of current in ampere. Now how many cells are there? 1, 2 and 3. Now if you see here, these two cells are connected in opposite polarity, right? Opposite polarity means if this is plus 1, this is minus 1. So these two cells will cancel each other potentials. So what is the net EMF? Net EMF is 2 volt plus 2 volt minus 2 volt, because this is minus, this one is minus, right? So net EMF is 2 volts only. Now what is the net resistance? Net resistance, in case of resistance, it does not matter. Resistance always gets added. There is no sign for resistance. So it will be 1 plus 1 plus 1, that is 3 ohm. So you can reconstruct this circuit as one resistance of 2 ohm and one battery of 2 volt and one resistance of 3 ohm. Okay, so what is the current here? Current here will be I is equal to 2 divided by 2 plus 3, that is 2 divided by 5. 2 divided by 5 means 0.4. So 0.4 is the current. Okay, simple. If you have any doubts, please don't forget to mention that in the comment. We have reached to the end of this video, and I hope that you have scored as much possible marks as possible, and mention your marks in the comment below. So we'll see you tomorrow with a new lecture. Thank you.